Still remember how to do 29? How do you do 29? Your hot vector diagram, find the resultant force. So 4 Newton plus 3 Newton. This is the resultant. Square root of square is 5. Okay, resultant is 5. And then direction 你要找 angle. 这里的 angle tangent minus 1 4 over 3 53.13. Okay, 53.13 is this angle. You find what about this angle? This angle x is okay. 180 minus, you get 36.9 angle. So direction is 36.9 anti-clockwise from 4 Newton force. So from 4 Newton force, 36.9 anti-clockwise. This is the direction of the force. Now, 通常我们给 direction 的时候，我们是拿那个 resultant force 放在那个 axis x-y axis. This is your x-y axis. You just take the resultant force, put it in here. The tail of the resultant force. See the direction. This is the arrow. That is the tail of the resultant force. You put it like this. Okay. So, 这里 the angle 53.13 degrees. Normally, this is how we give direction. We put the tail and the origin, and then the angle is from the y-axis. So that means 90 plus 53.13, 143 total angle, 143.13. So this is from y-axis. This is one way. Yes, it can be direction. How many angles from another force? Okay. One way is to give like this direction. Take the resultant, put it in the axis, and find the angle. Or you can also give the angle from another force. 你可以讲 4 Newton anti-clockwise. 不是偏激。你也可以讲 3 Newton clockwise. 53.13. There are many ways you can give directions. Okay. Answer 29 is boy. Question 30, you have to resolve the 2 Newton force first. Everybody is either vertical or horizontal, but the 2 Newton is diagonal. You have to resolve that one. Question 30. So you have 4 Newton. Then okay, so resultant force is downward 5 Newton. And then go with 3 minus 1.7. Okay. 1.268 Newton. Resultant starting to ending. Okay, question 31, three forces act on a particle. Question 31 is the same as question 30. It's just that the question they want to find what is the opposing force to balance it. So we know from question 30, we got resultant, right? So you need an opposite force to balance this one. That means you need to apply another force, same direction but opposite. Same line but opposite direction that counters it. Okay, this is for 31. Opposing force. 这个是你的 resultant 吗？我们先画这样子先。这个是5.2 Newton. Let's put the Cartesian easier to see. You put like this. Y. Okay. How much is the degree over here? Can we find that degree? We got here already 75.8. Then you need to find here. This is 75.8. This is 14.2. Okay, so I need another force. (5.2). This one angle here. This one angle here. 14.2. Balance it. Right. 这个是我的 resultant. 当你的 system unbalanced 的时候 this is from this question. You have a resultant here. So you want to balance it, you need an opposing force of 5.2 like this. Okay, so you know the magnitude, it has to be 5.2. DC is out. What about the direction? 14.3 and 345.7. Now, remember we said how we give direction? Take this one, put it in the Cartesian axis. The tail must be at the origin. The tail must be, see the arrow, huh? The tail here must be at the origin. This is you put it like this. Okay, so that means this is 14.2. The direction is from y-axis given 345.7. Answer is boy, 31.因为它没有 specify，你可以讲14.3，除非你有 specify anti-clockwise，可是它这边没有 specify，所以它的修你从 y-axis one clockwise， so answer should be boy. Question 37. Which of the following shows the correct vector diagram of an object in equilibrium? For equilibrium, either triangle is a closed triangle, closed triangle. And no neither direction, yes, all same directions. So meaning that if you start here, you add up all the forces, they should come back to starting point. Okay, so look at the direction also has to be one way. The direction has to be one way. If I do like this, here, and then suddenly this one like this. This is not equilibrium. Starting point, follow the direction. Here, it should be opposite going back. So this one is not in one direction. That is not an equilibrium system. That means two arrows cannot be equilibrium. If you have an object acted by two forces, two arrows, like this, okay, then this one cannot be in equilibrium. It's not possible because when you add these two, add with vertical, horizontal, vertical, you are not, two forces cannot go back to the same starting location. So it has to be unbalanced. So in this case, you will have a net force. Huh? How do you draw the net force? The net force is once you start here, you stop here, and then your net force is from start to end. Okay? Starting and ending. This is your net force. So in this diagram, you see there is a net force. Here, 这个是你的 net force. This is the net force. 37 is C. 38 C question. 38 is also C. Close triangle and same, all one-way direction. OK, tension 是多少来弄它 equilibrium？我先加，因为他没有给我 angle 哦，他没有给我 angle，所以我做不到 resolution。But I can add these two together first. This one is 20, this is 30. You add it up. What is 20 squared plus 30 squared? We get 36.06 Newton. 36 吧。OK， 所以那个两个加起来是36。Here, the resultant of these two, then the tension must be 30, 36 in the opposite direction. Okay, so the point 34，你先画你的 vector diagram。 整个 system 是 equilibrium, right? So if whole thing is in equilibrium, then I draw a closed triangle. The D MG. Then 50. Come back. Come all the way back. Why all the way back to the starting? Because you know it's equilibrium. Then you do MG. Okay. So 50 squared minus 30 squared equals to MG. Okay. 其实第一个你也是可以这样子做的，也是可以画你的 closed triangle 先。This one, then you find the tension. Question 49. We look at two more questions, 49 and last one. 49. Find the tension T1 and T2. Okay, so we got two objects. 4 strings, this is T1, and then we got T2. And this is 2 kg. Weight is 20 Newton. Now, we can't Newton label can put force then. 我们的 force 有多种 MA, MG, FT, R, and then up thrust. So in this case, it's all tension out of the object. This one also out of the object. Out of the object. Okay, free body diagram for the first object. That means you only take this part. Free body diagram 你就可以选一个 object 或者同时 one time one object. So here T2 T2. This is 20 downward. This must be 10. This must be 10 because the whole thing is balanced. Now, if this is 10, this one is on the same string. Same string must be the same one. 10, 10. Now I take the second object. Free body diagram for the second object. 20 downward. When you look at the second object, forget about the first one. 不要再看你第一个，看你的第二个。Okay, then 20 downward. How much is this one? 5. Okay, 5. This is how you analyze systems in equilibrium. Huh? You look at one object at one time, find the forces, use that, try to decide. Okay, so T1 is 5 Newton, T2 is 10 Newton. Body. 50 is almost the same. Question 50. So you got 3 springs up, then 2 springs, 5 kg. Oh, sorry, this is 2 kg. Label all forces, mg, T2, T3. 这里一样的 T2, T2, T1, T1, T1. Free body diagram of the first. This is 20, this is 10, this is 10. Now bring it here. You now know what is T2 already. T2 is 10, this is 10, this is 10, this one is 20 divided by sin T1 等于20。Sorry. Oh, sorry. I forgot one thing is that the beam has mass also, right? Here, it says that the beam has 1 kg. What does that mean? Meaning that you got the mg for this one, you got mg for this one, 10. Because it's 1 kg now. So the mg of the upper beam is 10. So you got 30 equals to 3T1. Yeah. Yes. Mg for this one is 10 Newton. T2 and 30 equals to 3T1. So T1 is 10 Newton. Answer is donkey. Okay, last question, 51. Label all the forces first. This is your list. MA, MG, FER. Okay. MG, MG, E come out, T come out, E come out, E come out. Okay, tension come out from every single object. So is that all? Yes, that's all of this. Okay. Now look at the whole thing, the whole system. We take all the body together in the system. F the lead, MA. Remember, this is your net. It says this is bigger. W is bigger than V. That means mg is bigger than this one. So we write Wg minus Vg. Is your net force. Bigger minus bigger. The whole thing goes like this one. MA, and this is your total mass of the system, because right now I'm looking at the whole system. So the mass is this add together, W plus G, W plus A. Do I care about the tension? No, because you're looking at the whole system. If you consider the whole system, then these two will cancel out. This will cancel out. If you consider one free body diagram, then you have to take the tension. You look at the whole thing, they all cancel. Right. You take only one object, you have to include the tension, just like what we did here. I take one body, I have to include the tension here. I look at the whole thing, they all cancel out. Okay, so certainly the exceptions G W to D 3 W. That is this. A.